This is going to be the second video on fractions, and in this video we are going to focus on day 8 through 14 or 15 with the assessment of your fraction teaching progression. So in this video we're focusing on 3.3F, which is representing equivalent fractions. We are focusing on 3.3G, which talks about explaining why two fractions are equivalent. We're focusing on 3.3H, which is comparing two fractions that have same numerator or denominator. And we are focusing on 3.7A, representing fractions of halves, fourths, and eighths on a number line. Okay, so we're going to start out with day 8 and 9, where we're talking about equivalent fractions. And I like to start out by, of course, concretely with this one. And you can use really whatever manipulative that you want. You can use your fraction strips. So I could put up the whole, right? And we could then, what equals a whole? Well, 2 halves equal a whole. And what equals, so I have a fourth, and a fourth, and so then we can have the discussion that 2 fourths equals 1 half, right? And then we continue going, and we could say that 3/3 equals 1 whole, and we could keep going, and we could say that our eighths, so we could keep going, and we could say that, and I can continue on, but we could say that 2/8 equals 1/4, and that 4/8 equals 1 half. But it's about kids seeing that all I'm doing is like taking a half and breaking it in half, and that's creating fourths, and taking a fourth and breaking it in half, and that's creating eighths. Okay, so it's about them being able to visualize, because once we get to comparing fractions, we're going to have to visualize that 4/8 equals a half, or it's close to a half, or that 3/8 is close to a half because it's more than a fourth. So the good news with equivalent fractions is that they will always have a pictorial model or a number line to represent the equivalent fractions. Okay, but I would start out with some sort of manipulative that students can manipulate to find equivalent fractions. These are good, as I said, the fraction strips are good, but I also like the Cuisenaire rods, because remember, any one of these can be a whole. So if I said, okay, boys and girls, I want you to find all of the colored rods that equal one brown rod, so students can then manipulate and see that, okay, well, 4 reds equals 1 brown. Let's see. Ooh, 2 purples equal 1 brown. I think 4 whites will equal 1 brown. And then from there, we can talk about our equivalent fractions as well. And this will be good when we get to comparing fractions as well later on. So I call this a color train, right? So I can say that 2 fourths equals 1 half, and I could say that 4/8 equals a half, or 4/8 equals 2/4. So kids have to see it, and then they're going to start seeing it when we represent it in a number line. So when we talk about equivalent fractions, we're going to start there. We can start drawing the models, and then this is how students are tested, just so you know. They always give them the pictorial model to look at, okay? And so for this type of question, you can have kids take their pencils and, for instance, I could say this one, well, if I take my pencil and I draw it just like it, I'm going to see that's a half. Well, I can automatically see this is more than half, right? So it's not equivalent. I can look at this picture and see this is more than this picture. I know this represents a half because it looks the same thing. And I could go through and mark this one, this circle fraction, like this one and see if it matches, but I know it does. So what I want you to understand is the fractions you're representing are the fractions that you're looking for to see if they're equivalent. Those pictures aren't always on top of each other or side by side. So students have to be able to have practice with finding the equivalent fractions that way. The number lines, of course, once again, when I look at this number line, I can see that X looks like it's right in the middle between 0 and 1, so students have to be able to reason that this is 1/2. And as I told you before, one way to help students see that once again is to go back to your fraction strip, right, and show them that this is the whole number line. If I break it up into a half, I'm going to have a line right in the middle, and that represents 1/2 of the whole, okay? And then you can work with students to say, okay, so I need to find the half point of all the rest of these number lines. This one's broken up into 1, 2, 3, 4, 5, 6 jumps. So it's broken up into 6 parts. So what's half of 6? Well, of course, is 3. So 1, 2, 3. This would be my half, and that's not where my Z is, right? And then I can do that. Once I know that's half, the rest of these number lines are lined up. So I can determine that H represents the same fraction as X does on the number line at the top, okay? So that's a little bit about equivalent fractions. Start concretely, then move them into pictorial. Maybe do a couple concrete, then have them draw it out, show them the pictorial models, show them the strip diagrams, have them do their own drawings, make sure they draw number lines as well, and just continually work on how do I know they represent the same fraction, right? Now, then we get into comparing fractions. What's great about your comparing fractions is that you're either going to have the same numerator or the same denominator. Now, you may have pictures. You may not have pictures. This may be just in a word problem. But, for instance, let's say I have two, I don't think it's, so 2/6, and I have 2/8, because they are the same numerator. And I'm looking at these, I have to be able to reason about fraction sizes. I don't want you doing any kind of tricks here with students. We're going to talk about 2/6 and 2/8 and how I can figure out one's bigger than the other. Well, if the numerators are the same, I'm going to look at the denominators. And I'm going to reason about the sizes of those denominators. So if I have a pie that's cut into 6 pieces and a pie that's cut into 8 pieces, which of those pieces are smaller? Or which of those pieces is larger? And hopefully I will say, well, if I have a pie that's cut into 6 pieces, my pieces are bigger than if I cut them into 8 pieces. So 2/6 is greater than 2/8. Okay, so that is the same numerator, and that's harder than even this next one, which is the same denominator. So if I have 2/6 and 4/6, I know I have a pie that's cut into 6 pieces, right? So I have 2 of those slices, or I have 4 of those slices of pizza, or pi. So which one's larger? Which quantity is larger? Well, definitely if I have 4 pieces, it's going to be larger than 2 pieces. Okay? So that's how we want kids to reason about fractions and their size, right? We want them to think about all the manipulatives you've used, think about the pictorial models you use, and reason about the sizes of the fraction, okay, without thinking of any other tricks or anything like that, all right? So that is comparing fractions. Now we get into, like once again I said, we're going to get into looking at exploring the number line with fractions beyond 1. Now, we have been looking at number lines since the very beginning of fractions because we've been representing fractions with number lines. We've been doing equivalent fractions with number lines. So we've been working with number lines this whole time, except we've been working with number lines that are less than a whole, okay, or just a whole. So we have been working with a number line where we have 0, we have 1, and we have possibly, we have this, and we have a dot here, and I want to know what A is. This is what we've been working on. We've been representing fractions. And I do want to show you a little trick here that'll help students. It helped my students when I taught, is that I turn this number line into a fraction bar because that's easier for them for some reason than looking at it like a number line. So I look for the 2 holes and I draw a fraction bar, okay? And then I go ahead and follow the lines down, and then I shade up to whatever dot, wherever my point is, I shade up to that. So I can very easily see now that I have 4 parts to this hole, right? And how many of them are shaded? 3/4. So this line represents 3/4 of the number line. On this day, what we have now is I may have this. I'm now going to practice what if my point that I'm looking for is past a hole, okay? So the same applies. I tell my kids, see if I got a new marker if this one works, to find the 2 holes that point is between. So this A, point A, is in between 1 and 2. So I am going to draw my fraction bar, okay? I am then going to draw on the lines. I know this wasn't totally 100% accurate here. And I'm going to shade up to point A, and I can see I'm after 1, so this has to represent a whole plus the fraction. So it's broken up into 4 equal pieces, so that's my denominator, and I only have 1 part shaded, so point A is 1 and 1/4. It is a whole and 1/4 of the number line, okay? So that is exploring number lines beyond 1. Day 14 and 15 are then just student practice and an assessment. Please let me know if you have any questions about fractions, if I didn't answer anything that you needed to know in video 1 or 2. If you want to know more about how to use the Cuisenaire rods to help you teach fractions, I will be glad to come out and work you through that and help you create your lesson with that. So until next time, we will let you go.